8.4. Solve polynomial equations in factored form. Okay, I'm going to teach you the zero product property to solve polynomial equations. Let a and b be real numbers. If a times b equal to 0, then a would equal to 0 and b would equal to 0. And we can use the zero property to solve a polynomial equation that has the following form: x plus a in parentheses times x plus b in parentheses equal to 0. And a and b can be any real number. So let's look at a numerical example here. X plus 5 times x plus 2. This is in factored form. Okay, so we have one factor of a here, x plus 5, and another factor of b, x plus 2. So I can set x plus 5 equal to 0 according to the zero product property. So this would be my a. And then I can solve for x, and that would equal to -5. And the same thing goes for x plus 2. I can let that be b. I can let it equal to 0, and then solve for x to get -2. Therefore, -5 and -2 are also called the roots of the equation. Now I'm going to show you how to factor expressions, meaning write a polynomial as a product. So here I have an example for you: 4x to the 4th power plus 24x cubed. And then between these two monomials, I need to find the GCF, which is 4x cubed. So GCF between 4 and 24 is 4. GCF between x to the 4th power and x to the cube power is x cubed. You take the smaller power. Now, I need to take this monomial and write it as one of the factors. Okay, and then this factor, or this monomial, will divide evenly into each of the terms you're about to write now. Now, 4x cubed times what number will give you 4x to the 4th power? This would be x by the distributive property. And then I need to add that to 6, because 4x cubed times 6 would give me 24x cubed. Now that you learned how to factor expressions, we're going to learn how to solve a polynomial equation using the zero product property. Okay, if we look at the example to the right here, it's a polynomial equation that's not in factored form. So we need to rewrite this polynomial as a product, which I just showed you earlier. So we need to find the GCF between these two monomials. So between 2 and 8, 2 is the GCF. Between x squared and x, the GCF is x. So 2x will be your entire GCF. Now, 2x times x would give you 2x squared plus 4, because 2x times 4 will give you 8x. So this product form still equals the original polynomial equation. And again, we need to write this as equal to 0. And now we can solve this polynomial equation. This will be your a. So we'll write it over here. 2x equals to 0, then x equals to 0. This will be your b. X plus 4 equal to 0, and x would equal to -4. So you have two answers. X can equal to 0 or -4. Now let's look at another example. 6n squared equals 15n. Well, I wouldn't cancel out n just yet, because you're going to end up with 6n equal to 15, and then n would equal to 5 over 2. Now we're missing one answer here because this square tells me that I have two answers. Now I need to rewrite this polynomial as 6n squared minus 15n and let it equal to 0. And then I can factor out the GCF of 3n. So this would be multiplied to 2n minus 5. So let's double check. 3n times 2n, 6n squared. 3n times negative 5 is negative 15n. So there 3n equal to 0, n equal to 0, 2n minus 5 equal to 0, n would equal to 5 over 2. You see earlier I showed you that one of the answers was 5 over 2, but you were missing the answer 0. So you need to rewrite the equation so that it's set equal to 0, and then you need to factor out the GCF and then use the zero product property to find your answers. Before I teach you about the vertical motion model, let's first practice factoring expressions and solving some equations. Okay, for this first example here, the GCF will be 5ab, and then we need to multiply that to 7ab. So this will get 35a squared b squared. And then this, because this is already 5ab, we just write 1, because 5ab times 1 is still 5ab. And this will be in factored form. Okay, let's now look at the next example. You have a negative sign here, so we need to factor that out. So I'll show an extra step. Negative 3p to the 4th power minus 15p squared minus 6p. So then when you distribute the negative 1 in, the signs will still be the same when you look at it backwards. And now you need to consider the monomials. Since you have a 3, 15, and a 6, the GCF is 3 between all the numbers, and the GCF between all the variables will be p. And don't forget your negative sign. Okay, so here I would do p cubed, because this will still give me negative 3p to the 4th power. And here I would do 5p. This will still give me negative 3 times negative 5, positive 15, and then p squared. And the last one will be 2. So double check, negative 3p times negative 2 will still give you positive 6p. So this is your answer. Okay, now we had to solve equations using the zero product property. So as I said earlier, when you get an equation like this, you need to rewrite it so that it's a 0 on one side. Negative 30r squared plus 25r equal to 0. So I move this over. Okay, now I need to factor out the numbers, which is, and the negative sign too, and that would be negative 5. And now I'm going to factor out the r. So negative 5r times 6r will still give you negative 30r squared, and a negative 5r times negative 5 will give you positive 25r. And now we can solve. Negative 5r equal to 0. R will equal to 0. And your other one, 6r minus 5 equal to 0. R will equal to 5 over 6. So these would be your answers. We have one more. Negative 10 and positive 35. Factor out the negative 5, and then we're going to factor the n out. So this will be 2n and minus 7. Negative, negative, positive, 35n. Okay, so negative 5n equal to 0. answer. Okay, now let's look at another one. X squared and x, I factor out the x because between 2 and 15, there's no GCF. So this would be 2x plus 15. So then x would equal to 0, 2x plus 15 equal to 0, and this would be x equals to negative 15 over 2. Okay, let's look at one more. You factor out the negative sign, and then the GCF between 32 and 24 would be 8. Between y squared and y will be y. And we'll multiply this GCF to 4y and plus 3, because negative 8y times positive 3 will give you negative 24y. Okay, and negative 8y equal to 0, y will equal to 0. Okay, and then the next one, to find the zeros of the function, we just need to let this f of x be 0. So 0 equals negative 28x squared plus 7x. We do the same thing. We can factor out the negative sign, and then we need to factor out the 7 and the x. And then here this would be 4x, so this would still make negative 28x squared. And then we would subtract 1, because negative 7x times negative 1 would give you positive 7x. Okay, and then now we can solve. X would equal to 1/4. Okay, now I'm going to teach you what the vertical motion model is, and you will definitely need to use this model for your projects. Okay, here we have what we call the vertical motion model. H of t equals negative 16t squared plus vt plus s. H here represents the height, and t stands for the time. The v stands for the initial vertical velocity, okay, meaning the beginning. And s stands for the initial height at the beginning of the motion. Okay, in 9.1, which you'll learn later, you'll learn that what you've been doing all this time in chapter 8 is the quadratic function. Y equals ax squared plus bx plus c. Now, I can replace y with h of t and ax squared with negative 16t squared, and bx with vt and c with s. And I already defined everything for you earlier. Now I'm going to explain what negative 16t squared means, or simply what this coefficient means. When gravity pulls objects toward the center of the Earth at an acceleration of 32 feet per second squared, we need to use the average as acceleration per second. So 32 divided by 2, 16. So that's where it comes from. So this is a fact. The negative sign is because the acceleration is downward. And think of when you hit a tennis ball with a tennis racket, think of the motion in which the ball travels at. It has to be a parabolic motion. So what I just said earlier, parabolic motion. And of course, this is a parabola. And we'll talk about this term later in chapter 9. So let's look at a simple example here. A tennis player hits a ball from a height of 3 feet above the ground at an initial velocity of 10 feet per second. How high off the ground would the tennis ball be at 0.5 seconds? So if the initial velocity is given at 10 feet per second, I can substitute v for 10. And then the tennis ball at the beginning is 3 feet. So I can substitute s for 3. And then I can substitute t for 0.5. So now let's set this up. h of t equals negative 16, 0.5 squared plus 10 times 0.5 plus 3. And after doing all the math, you should get 4 feet above the ground after 0.5 seconds. Now let's look at the picture here. If this were 1, 2, 3, and the tennis ball was hit at this point, and this is 1, and after 0.5 seconds, this tennis ball will be at this point of 4 feet. So here it's labeled. Okay, so this is the vertical motion model. It travels from a certain point in a parabolic path and eventually hits the ground when h equal to 0. Okay, let's look at this next example here. A diver jumps from a diving board that is 24 feet above the water. So here this would be the initial height, and the height of the diver is given by this function here, where the h is measured in feet and the time t is measured in seconds. When will the diver hit the water? So when the diver hits the water, the height will be 0. So I can substitute 0 in for h. And since this function is already in factored form, I can go ahead and use the zero product property and solve for t. So one t will be 1.5 seconds, and the other t will be -1 seconds, but -1 doesn't make sense, so your answer has to be 1.5 seconds. Okay, let's look at this last example here. The shape of an arched doorway is modeled by the graph of the function y equals negative 0.5x times x minus a, where x and y are measured in feet. On a coordinate plane, the floor is represented by the x-axis, so right here. How wide is the doorway at its base? Now, since this function is already in factored form, we can simply let y equal to 0, because at the base, the height of this doorway is always 0. So to solve for x, we can do this. X equal to 0 and x minus 8 equal to 0. So x equals to 8. Well, when x equals 0, that means it will be this part of the doorway. When x equals to 8, it will be at this point. So 8 minus 0 would give you the width of the doorway, which is just 8 feet. Now part B asks us for the doorway's highest point, and this will occur at the center of the base, which is 4. So how high is the highest point of the arched doorway? So I took the function and I distributed the negative 0.5x into x minus 8, and I got negative 0.5x squared plus 4x. Now I added this 0 here just because this 0 tells us that it's the initial height. Okay, when s is 0, according to the formula I taught you earlier, and the end height is also 0. So what I'm talking about is these 2 points. Okay, so we can go ahead and ignore this part. Now, the negative 0.5 does not follow the vertical motion model because this problem is about a structure, so there's no motion involved. So we can go ahead and substitute 4 in for x because that's the midpoint. And at the midpoint, it will give you the highest point. So after doing all the math, you should get 8 feet. So I can plot this point at 4, 8. And you can draw your parabola. And so this will be your doorway. So if this was a door, and you got your handle. Okay? And this concludes the lesson.